Okay, the purpose of this podcast is to explore the relationship between a function, its first derivative, and its second derivative. So here you see a cubic polynomial, the red function, and clearly its derivative, which is quite straightforward to calculate, right? 3x squared minus 12x plus 10. So in blue, you see the first derivative of the function, the so-called gradient function, or a newly derived function that's describing something to do with the rate of change of the first function. And then, of course, the derivative of the derivative, namely the second derivative, simply is 6x minus 12. So this function says something about the rate of change of this function. So let's consider the interplay amongst these three. So let me do my version of an animation. So we'll go through about 6 slides here and just have a look, and then we'll recap and go back and start it again. So here we are with a blue tangent line coming in relative to the red function, and something's dropping down. Here's that tangent line now, not coincidentally, sort of coming in right at the local maximum of the red curve. Here, that blue tangent line sort of wrapped around that part of the curve so far. We'll pause it there, and then it wraps around even further, gets to what would be the local minimum point, and then we're over on the other side. And then it's gone, right? So in the process of looking at the lines drawn tangent at various interesting points to the red function, we saw something else formed. So let's go back. Here's our beginning. So what's happening? So the y values in red are the proper y values, but these derivative values which are starting to show up, namely this dotted parabolic curve that's starting to form, those aren't y values anymore. Those are actually first derivative values. So the slope of the line drawn tangent to the curve at this particular x value right about here, that slope value is actually right here, about 1.6-ish, right? That's actually what that's trying to say. So if we go a little bit further, and now we freeze frame it and say, well, geez, the slope of the line drawn tangent, interestingly enough, to the red curve right at this local max, it dropped from 1.6, if you will, to 0, not surprisingly. And we'll note also that these slope values of these lines that would have been coming in tangent to this curve until we froze it here, what were those slope values doing? Well, first of all, they were positive because all of those lines were rising from left to right. So, they're all positive. They're all up here above 0. They're all positive values. And they were getting smaller, right? They were getting smaller to the point where they eventually hit 0. Well, here, these are the values that are actually getting smaller until we hit 0. And then we keep going, right? We wrap around. So our slope values, the slopes of these lines drawn tangent, we're just freezing a couple of them here for you. Those slope values, as we transition across that threshold, they still continue to decrease. Well, here they are. They're continuing to decrease until when? Until this interesting point right here where we freeze it, right? And so that is an interesting place in x because the concavity of the red curve is changing now. It's about to change from concave down to concave up. And so those slope values, as we wrap around that point, they kept dropping and they stayed, but they were decreasing the whole time until right there. And then boom, we had to come over on the other side of, or the underside, if you will, of the red curve in order for those slope values to suddenly start increasing. And here they are increasing until, lo and behold, right here, where the slope of that line drawn tangent, right at that local minimum point, that's exactly 0. And then if you keep going, suddenly we're over on the other side. And of course, these lines now are rising from left to right, these blue lines, and they would have positive slopes, and that's where we're starting to pick up with these positive values right here. And then it would be out of the picture. And so, interestingly, we get a first derivative, that blue outlined parabolic curve there we saw earlier in blue, and we'll go back to it in just a second, is actually the function in question. And look, the zeros, right, where that first derivative hits 0 there is correlating to a local max. Where that first derivative hits 0 there, that's where it's correlating to a local min. And then interestingly, where there's this transition here, we'll talk more about that in just a second, where the concavity changes from concave down to concave up, there's something interesting happening with the derivative there as well. So let's go back and take a look. Of course, what we're talking about there is this parabolic blue dotted derivative function. That is the function right there. And what's this guy doing? Well, this is the second derivative, which should be saying something about the rate at which this function is changing. Because after all, if this is the gradient function, or the rate of change of this function, then this newly derived function called the derivative, it also is just a function, and the derivative of the derivative, this guy here, he describes the rate of change of that one. And so what would be happening there? I don't have it for you visually, but if you were saying, what about the slopes of lines drawn tangent now to this blue curve? Well, all of these slopes, as they'd be drawn tangent left of this vertex, those are all negative slope values that would be getting bigger and bigger and bigger. They'd be getting less negative, if you will, until they got right here where they would hit 0. Well, here they are. Here's the negative slope values getting less and less negative until, boom, we hit 0 right there, right? So that function, that linear function, is exactly describing the rate at which this blue dotted first derivative is changing. And then there's this transition. We shift over to the other side, and those slope values, if I started to draw in for you, slopes of lines drawn tangent to the curve over, whoops, on that side, sorry about that, they would actually be positive, and they'd be continuing to grow. And that's why we see what we see in terms of the relationship between the second derivative and the first derivative. So there it is, for what it's worth, kind of an animation thing, and we end up right where we began. Hope you found that useful. Thank you. Bye.